In this video, I'm going to talk about gears and demonstrate how gears work. As you can see, I've attached some gears to this plate. Let's focus on the red gear in the lower corner. My hand will act like a motor, and when the motor spins, the gear turns. Well, what happens if I add a yellow gear right here? Okay, notice it is connected to the red gear. So when the motor spins the red gear clockwise, the yellow gear spins counterclockwise. One tooth from the red gear pushes the tooth of a yellow gear down, but that causes the tooth of a yellow gear to push the red gear down, and it just keeps going and going. Notice also these two gears are the same size and both have 8 teeth. So when the red gear makes a complete revolution, the yellow gear also makes a complete revolution, just in the opposite direction. Now what happens if I add another red gear right here? Now the whole line of gears spins. Let's look a little more closely. Look at all the red gears. Do you notice? They all spin clockwise. And all the yellow gears spin counterclockwise. Gear 1, clockwise. Gear 2, counterclockwise. Gear 3, clockwise. 4, counterclockwise. 5, clockwise. And 6, counterclockwise. In fact, all the odd gears, no matter how long the line is, they'll spin the same direction as the first driven gear. And all the even gears will spin in the opposite direction compared to the driven gear. Pretty cool, huh? But gears don't just work in a line. What happens if I add another red gear right here? What do you think? Oh, all the gears spin. And look, once again, all the red gears are spinning clockwise because they're all odd numbered gears. The yellows spin counterclockwise because they're even. But you aren't just limited to working in a single plane like this. I think you can guess what's going to happen when I add this tower right here. But the question for you is, what about this red gear right here? Do you think it's going to spin? If so, do you think clockwise or counterclockwise? Is it an odd number or an even number? Let's find out. Did you say clockwise? 1, 2, 3. It's an odd number, just like the driven gear. Good. What happens if the gears are different sizes? If they have different number of teeth? Well, let's look at the dark bluish gray gears found in your redo set. The small gear has 8 teeth, while the large gear has 24 teeth. Remember, one tooth causes the tooth on the opposite gear to move. Here, I've connected the 8 and 24 tooth gears inside a sturdy frame, and I've attached Lego bricks to the axles so you can see how quickly they rotate. Let's pretend the small gear is attached to the motor. I'm going to spin it one time around and watch the other axle that's connected to the large gear. When the small gear spins once, has the big gear spun around? It hasn't yet. It's only gone through 8 of the 24 teeth. In fact, I need to spin the small gear a second time and a third time for the big gear to spin around once. Why? The small gear has 8 teeth. 8 teeth plus 8 teeth on the second revolution plus 8 teeth on the third revolution equals 24. 8 plus 8 plus 8 is 24. And that's how many teeth are in the big gear. Well, what happens if I attach the motor to the big gear and spin it around one time? Do you have a guess? Let's find out. I'm going to spin the big gear one time. Look at that. The small gear is spinning faster than the larger gear. It's spinning faster than the motor. That is mechanical advantage that we can use when we build with Lego.